Dear students, once again welcome to our Blackboard Education channel. Today in this session we are going to discuss about 10th class chapter 2 chemical equations as part 4, making chemical equation more informative and interpreting a balanced chemical equation. Let us begin with a concept making chemical equation more informative. In previous session we have discussed about that how can we write a balanced chemical equation. We can make a chemical equation more informative by stating its a state and whether the heat is liberated or heat is absorbed or the gas is evolved or precipitate formed by taking a special symbols. Let us start with one of the important point, that is expressing the physical state. To make the chemical equation more informative, the physical state of the substances may be mentioned along with their chemical formulae. The gaseous state is represented by a notation G, liquid as L, and solid is represented by a notation S. If the substance is present as a solution in water, the word aqueous is written. In the short form, it is written as AQ. For example, when sodium is dissolved in water, it gives a sodium hydroxide and hydrogen is liberated. So here, sodium is a solid substance, so it is represented as S notation. Water, a liquid state, L. Sodium hydroxide, it is aqua, AQ. And hydrogen is a gas. We have to state it by writing it as G. G stands for gas. Here is another example. Iron oxide, Fe2O3, it is a solid in state. We have to state it as S, plus aluminium, also solid state, yes. Iron, also solid state, yes. And aluminium oxide, that is Al2O3, is also a solid state. Now, we can make the chemical equation more informative by expressing the heat changes. Heat is liberated in exothermic reaction, and when the heat is absorbed in any chemical reaction, we used to say it as a endothermic reaction. For example, when carbon burn in air, means reacting with oxygen, it gives us carbon dioxide, and in this reaction the heat is liberated. So it is nothing but exothermic reaction. And when sodium is reacted with oxygen, it gives us nitric oxide, NO. It is heat is absorbed. Both of them were more stable gases. To react nitrogen with oxygen, the heat should be supplied to them. So absorbing the heat, this nitrogen react with oxygen to gives us nitric oxide. So here Q is a heat energy, which is shown with plus sign on product side for exothermic reaction and minus sign on product side is endothermic reaction. So in above equation, here plus Q shows that heat is liberated, and minus Q to the product side shows that heat is absorbed. One more thing is expressing the gas evolved. If a gas is evolved in a reaction, it is denoted by an upward arrow or a notation G. For example, zinc reacted with sulfuric acid. Zinc reacted with sulfuric acid to give us zinc sulfate and hydrogen gas liberated in this reaction. So zinc is a solid material, so we have represented it as S. H2SO4 aqueous solution AQ. Zinc sulfate is a solution AQ, and hydrogen is a gas. So here hydrogen we have written besides H2 upward arrow mark, showing that in this reaction gas is evolved. Expressing precipitate formed. In some kinds of reaction, a precipitate forms, means which is insoluble in water. For example, silver nitrate, when reacted with sodium chloride, it gives us silver chloride and sodium nitrate. Here, if a precipitate is formed in any reaction, it is denoted by downward arrow mark. That's why here HCl, silver chloride, here it is written downward arrow mark, showing that silver chloride is a precipitate form in this chemical reaction. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. are indicated above and or below the arrow in the equation. For example, silver chloride AgCl, when it is exposed to the sunlight, it is decomposed as silver and chlorine gas is evolved in this. So here that condition is sunlight, so we have to write it above the arrow mark. Let us see one more example. Carbon dioxide with water gives us glucose C6H12O6 plus oxygen. It is nothing but photosynthesis reaction. In this photosynthesis reaction, plants absorb water from the ground and taking carbon dioxide from atmosphere, it produces glucose, starch. So here sunlight and chlorophyll, both of them is also required to prepare this starch. So here that sunlight and chlorophyll we have to write either on the above the arrow mark or below the arrow mark. So in this way, here in some times the reaction conditions like pressure, catalyst, temperature, etc. are indicated above or below the arrow mark in the equation to make the chemical equation more informative. Now let us see interpreting a balanced chemical equation. What the balanced chemical equation gives for information gives for us. A chemical equation gives information about the reactants and products through their symbols and formulae. It gives the ratio of molecules of reactants and products. As molecular masses are expressed in unified masses, the relative masses of reactants and products are known from the equation. If the masses are expressed in grams, then the equation also gives the molar ratio of reactants and products. If gases are involved, we can equate their masses to their volumes and calculate the volumes or those gases liberated at a given condition of temperature and pressure using molar mass and molar volume relationship. Using molar mass and a Avogadro's number, we can calculate the number of molecules and atoms of different substances from the equation. It gives the information about relative masses of reactants and products. From the equation, we get mass-mass relationship, mass-volume relationship, volume-volume relationship, mass, volume, number of molecules, relationship, etc. So these are the information we will get by writing balanced chemical equation. In next session, we will discuss about applications of chemical equation. How these chemical equations are useful for us in our daily life situation. Thank you. Have a nice day.